In this video, we're going to take a look at the different ways that a line and a plane can intersect. So there are three different ways that we can have intersection between a line and a plane. So option number one is that the line can pass through the plane and intersect it at one single point. We would call that intersecting. And our description would be that the line and the plane cross at one point. Now a solution is where the line and the plane touch, which would be at one single point, so it would have one solution. Okay, another configuration we can have between a line and a plane is the line can be on the plane. We call that coincident. Since the line is lying on the plane, it intersects that plane every single point on that line. So I'm going to say as my description that the line is on the plane. And the number of solutions would be infinite because there's an infinite number of points where that line is touching that plane. All right, our last option is that they can be parallel. So to show that they're parallel, we usually put a little dotted line in and a 90-degree angle to show that they're evenly spaced. So if they are parallel, they would have no solution. So I wrote that it was parallel, and my description is that the lines are parallel. And they have no solution, so there are 0 solutions. Okay, we are going to take a look at one example of solving. There is a little song here, but I don't have the voice to sing it today. So I will read through it. It says, to find the point of intersection between a line and a plane, we write the line as parametric, and then we sub it back into the plane. X for x, y for y, z for z, simplify, find the value of the t, and then sub back in, find x, y, and the only way to make it rhyme was say z. Okay, so we're going to try that. We're going to do an example here. So it says, determine the intersection of the following lines with the plane 4x plus 3y minus 2z minus 5 equals 0. And then it says include a geometric representation, which just means draw a picture. So this is the plane. I know it's a plane because that's the scalar equation that we talked about yesterday. And then this is our line. I can tell because it has r and it only has one direction vector. So my instructions on the side say to find the point of intersection, we're going to take our line and write it as parametric. So that means x is going to equal 5 plus 2t. Y is going to equal 1 minus 4t. And z is going to equal negative 3 plus 1t, or just t. And then it says we sub it into our plane. So I have 4x plus 3y minus 2z minus 5 equals 0. So it says we do x for x, y for y, z for z. So I'm going to put each of these in place of their letters in the formula. So I'm going to have 4 times x, which is 5 plus 2t. And then 3 times y, which is 1 minus 4t. And then minus 2 times z, which is negative 3 plus t. And then I'm running out of space. We still have a minus 5, and then that equals 0. Okay, from there, we just need to solve for t. So I'm going to do some distribution. We're going to multiply all those numbers in front of the brackets into the brackets. So 4 times 5 is 20. 4 times 2t is 8t. Here there's a little secret 1 in front that we're going to multiply by. So 1 times 1 is 1. 1 times negative 4 is negative 4t. Negative 2 times negative 3 is positive 6. And negative 2 times positive t is negative 2t. I still have that minus 5, and then it equals 0. All right, we're going to collect up our like terms. I've got 8t minus 4t minus 2t. So 8 take away 4 is 4, take away another 2 is 2t. And then we have 21, that makes 21, plus 6 is 27, take away 5 is 22. That still equals 0. And then we're going to rearrange for t. So I'm going to subtract 22 from both sides to get that 2t equals negative 22. And then divide both sides by 2 to get that t equals negative 11. Okay, our last step, we found the value of the t, so we're going to sub it back in and find x, y, and z. So I'm going to go back to my parametric equation, and I'm going to put negative 11 back in to calculate. You could also go back to the vector equation, put negative 11 in, and calculate there. Actually, why don't we do that? I'm going to use that vector one. It's a little less writing. So we're going to say that our r is 5, 1, and negative 3. And then we're going to do plus t. It's a minus 11. So I'm going to do minus 11 times 2, negative 4, and 1. We're going to multiply that in. So I'm going to end up with 5, 1, negative 3. I'm going to leave the minus and just multiply by 11. So I'm going to get 22, negative 44, and 11. And then from there, I'm going to subtract. So 5 take away 22 is negative 17. 1 take away negative 44, I'm actually going to add 44 to get 45. And then negative 3 take away 11 is going to give me negative 14. So the fact that I got a point tells me that my line and my plane intersect at the point negative 17, 45, and negative 14. So I'm going to say, therefore, they intersect at negative 17, 45, and negative 14. And then it did ask for a geometric representation, so there would be a plane, and then my line is going to somehow intersect at one single point, and that point is negative 17, 45, and negative 14. We have one more thing we need to fill in, and that is what to look for when you're solving. So if we're going to get a point where they intersect, we will solve, and t will actually work out to be something. Right? So you'll end up getting t equals a number or s equals a number. If they are coincident, it's the same as when we were solving with intersections of lines. You should end up that all of your t's cancel out and all of the numbers cancel out. So you would get 0 equals 0. And if they happen to be parallel, then you would get 0 on one side and a number on the other. So two things that aren't equal, which is why there's no solution. Okay, I hope that helped. If you take a look, you can find the posted solutions in Brightspace as well, and then hopefully you can follow those to do the other questions. Have a great rest of your day.